Today, we are going to look at two more transformations. So last time we looked at different types of reflections and symmetry and what that meant on our figures. But today we're transitioning over to what is this going to look like on the coordinate planes with X, Y, and coordinates. Now, we looked real quickly last time at what happens when we reflect a figure over the X-axis or over the Y-axis. So let's review that real quick first, and then we'll take a look at our new reflections, and we're going to look at some rotations today as well. So if you remember from last time, if we reflect any image over the X-axis, so again, looking at our figure, our X-axis, that's going to be the horizontal axis. If we were going to reflect anything over that axis, again, that means that we're basically flipping our figure down over that line. So remember, if you're moving things from being above the line down to below the line, that means all we're going to change is our Y coordinate. And so we have a new way of looking at these rules too, that we're going to start using this notation. If we're starting with the points X, Y in any format, well, if all we're doing is changing the Y coordinate, then our new rule would look like, instead of X, Y, our new points would be X with negative Y. So if you compare the points that we have, A and B on the graph that's already drawn, and our new versions, you'll notice all I did was change the signs. So this is the same thing we did last video, but let's go ahead and graph it and see how it looks. And again, we could use the trick as well. If we can see this on the picture, then all we have to do is count our spaces. So A, that point is one above the line. So we would reflect it down to do one below the line. And again, our new version, we would call A prime. B was 3 spaces above the line. So to reflect it, we would put 3 spaces below the line. That's where our new B prime is. And there's our new segment reflected over the X axis. So we also did Y axis reflection. So our Y axis, don't forget, that's your vertical axis. So that means we're flipping things left to right. So instead of changing the Y coordinate, we're changing the X coordinate. And again, with these reflections, all we do is change the sign. So any point X, Y, if all we do is change the sign on the X, our rule would look like negative X, Y. And again, that's just a summary of what we're doing to those coordinates. So now our new A prime would be, again, if it was for the left, we go 4 to the right. So our new A prime would be at the point 4, 1. Our new B prime, well, instead of going 2 to the left, we go 2 to the right. So B prime is at 2, 3. Perfect reflection over that Y axis. So what if our lines aren't straight? And so there are 3 types of reflections that we're also going to need to look at. And these are over the line Y equals X, over the line Y equals negative X, and a reflection about the origin. And we'll talk about that in a second. So let's look down at our next set. So first one we're going to take a look at is reflection over the line Y equals X. And so we have a few graphs over here first to use, but first, where is that line? So think back to when you were graphing lines in Algebra 1, or when we did a little bit of graphing in parallel lines. Well, if we have the line Y equals X, again, we're comparing that to the line Y equals MX plus B, except it doesn't look like we have any numbers in front of the X, and we don't have a B value. So that means our intercept is going to be at 0, 0, and we're just going to have a straight slope of up 1 over 1. And so here's our line Y equals X. And when you're doing these types of drawings, I would always suggest drawing this out on a graph. Okay, so if we're going to reflect over that line Y equals X, everything, all of our points, A and B, they have to flip right over that line. And what's going to happen, if we explain this using our rule, is actually all we're going to do is switch our X and our Y coordinates. So what this is going to look like is if we started with any coordinates X, Y, our new point is going to be Y, X. In other words, we're just flip-flopping where our numbers go. So let's see what this looks like and see if this rule actually works. So that means if we have the point A, negative 4, 1, if we just flip-flop the numbers, our new point A prime would be at 1, negative 4. our new point B prime. Again, original point was at -2, 3. So new point is going to be at 3, -2. So let's plot those out and see what happens. So A prime at 1, -4. So over 1 down 4. There's our new A prime. B prime at 3, -2. And so if we check out where these are, again, we can actually draw, let me change my color for this. So let's go over to green. So if I was to draw a line between my A points, again, notice I'm going straight across that line of reflection. Exactly what we did when we were sketching these out by hand. Same kind of thing with the B to the B prime, straight across. It's just hard to eyeball when we're on the grid if we're not going straight along the grid lines. Alrighty, let's check this out for the line y equals -x. So if I change my slope, let's see, y equals x, we have the slope going up to the right. So that means y equals -x. Now the slope is going to go up to the left. So our new line is going to be this one. And again, I know my line is not perfectly straightly drawn, but still, it can give a good idea. And it looks like what we're going to have to do is our segment's just going to have to kind of flip over that line. Although let me draw that top left part a little bit better. I want to make sure I'm going right through the grid lines. There we go. Alrighty, so for this, we're going to have to do more than just switch the x and the y's. For this, actually, we are also going to switch the signs. So kind of our notes on what we're doing. Not only do we switch the x versus the y, we're also going to change the signs. So we would look like -y, -x. Flip the order and flip whatever sign you were given. So that means our new A prime is going to be -1, +4. So again, I'm comparing to my original A coordinates, which I have written up in purple right above the chart. Our new B prime, well, again, flip-flop where they are and change the signs. So we're going to have a -3, +2. So again, let's see if that works. So -1, +4. Actually, let me change colors so I can see the contrast with the red line. Let's put this in green. Okay, so -1, +4. There's our A prime. B prime is at -3, +2. B prime. It does overlap the line we started with, but you'll notice everything is still that same distance away from that red line, y equals -x that I drew. Okay, our third reflection is a reflection about the origin. Now, this sounds a little bit weird, but basically what we're thinking about is if we looked at our point and we kind of drew an imaginary line going towards the origin, we're going to keep going the same distance away on the other side of it. So let's actually sketch this one out first and then write out our rule. So our A point starts at -4, 1. So I want to go the same exact distance, but on the other side of the origin. So that means I'm totally flipping things around. So my new A prime, is going to be at 4, -1. So you'll notice instead of going up 1, left 4, I totally reversed it. I went down 1, forwards 4. Let's think about that in terms of our points. So our original A was at -4, 1. Our new A, our A prime, was at 1, -4, excuse me, 4, -1. What did we do to it? Yeah, all we did was flip the signs. So we're going to change our signs. That's our rule. We can write our shortcut rule. XY would change into -x, -y. And now we can figure out our B pretty easily. Our original B, again, was at -2, 3. So our new B, B prime, would be at 2, -3. So 2, -3, there's our B prime. But doesn't it look like everything got twisted? Yeah, keep that in the back of your brain. It almost does look, I just did a rotation on that one. So keep an eye out for that when we do our rotations in a second. So let's look at a couple more examples. So we're going to perform the following reflections on the triangle. So let's up the ante, use a different shape. So here we go. So each one of these reflections we're going to do on our blue triangle. But our blue triangle, that's kind of what we're starting with. So I'm going to actually rename that guy. I'm going to call that PRE. Let me center that a little better. PRE for pre-image. That's our starting value. I'm going to write that vocab down in a little bit. So next one, we're going to reflect that pre-image over the line y equals x. Well, what was our rule for y equals x? Just flip-flop our coordinates. Okay, so original point 2, 1 will become, or 1, 2 will become 2, 1. And we'll have a 5, 1, and we'll have a 4, 3. So let's plot that out. So 2, 1, 5, 1, and 4, 3. Here's our new triangle. So I'm going to label him as triangle 1. But also 2, let's go ahead and draw that line y equals x to see, did it really work? So again, y equals x is going to go straight through our grid lines. That worked perfectly. Okay, what did we do for y equals negative x? Again, we did 2 things to those x coordinates. And change back to kind of a reddy purple. Okay, so not only did we flip-flop the order of the x's, but we also changed the signs. So our point 1, 2 is going to become the point -2, -1. Flip everything for this line. So -5, -1, -4, -3. Again, let's draw in our line. So y equals negative x is going to go the other direction. So it's going to go up to the left. And with where our original image is, our blue pre-image, that means I think I'm going to be reflecting it kind of down to the left of the graph, maybe close to the axis. Let's see where the points put it. So -2, -1, -5, -1, and -4, -3. There's our second image. But again, it looks like it went straight across that purple line for the new picture. Okay, reflecting about the origin, what did we do for that? And just one change, and that was changing the signs. So the point 1, 2 will become -1, -2. We'll have -1, -5, and -3, -4. Alrighty, so again, it should look like it went straight through the origin on the other side. I think it's going to be kind of right below that purple 2 triangle. Let's see what happens. So -1, -2. We have -1, -5, and -3, -4. There we go. Straight across from that origin. Awesome. Oops, deleted a little bit more than it wanted to. So there's our 4 triangle. All right, so those are reflections. Now let's look at some rotations. Now, again, I don't want you to get bogged down in the rules for these, because honestly, when I think about rotations, I actually only have one set of steps that I follow, and it works for every single rotation. Let's look at a couple first, and then see what we can do with them. Here we go. So again, you'll notice right on top of my graph, I have my points recorded again. We're going to start this with the same segment that we used before. Okay, here we go. Rotate 90-degree clockwise. So I know it's probably been a long while since y'all looked at a regular watch, but think about how the hands on an old style clock face work. They go around to the right. So a 90-degree clockwise turn, again, around to the right. 90 degrees is going to be one quadrant on our graph. So our A is going to flip around, actually be a little closer to the y-axis. Our B is going to flip around, be a little closer to the x-axis, but all in that first quadrant. The rule that we use is we are going to change our coordinates to y, -x. So in other words, we're flipping our coordinates and we're changing the sign of that x. So flip x, y, and then we're going to change our signs. So change original X sign. So that means our point A at 4, 1, our new A point is going to be 1, 4, because that 4 started out negative. Our new B prime is going to be 3, 2, because again, the 2 started out negative, we have to flip it around. So our new points at 1, 4, there's our A. 3, 2, there's our B. And again, if you drew this out on paper, or if you printed out this copying the notes and you're kind of annotating your notes as you go, think about if you took your paper and you twisted it 90 degrees, that's where your new segment looks like it's ending up. Okay, 180 degrees counterclockwise. So that means we're going the other direction. So instead of going around to the right, we're going around to the left. But 180 degrees, how much of a turn is that? That's a full half turn. So we go 90 degrees is one quadrant, 180 degrees, we're taking it into that fourth quadrant. Okay, so our rule for this, wait a second. Isn't that the same thing as a reflection in the origin? It's in the same place. And in fact, a reflection in the origin is exactly the same thing as a 180 degree rotation. So we're going to use exactly the same rules. And the only thing that we did for those is we changed our signs. So change signs. So our original A was at -4, 1. Our new A prime is going to be at 4, -1. Our new B prime, again, flip your signs around. So you were at -2, so that means we need a +2 and a -3, completely flipped around. New points, 4, -1, A prime, and B prime at 2, -3. However, there's a little bit of a trick that I like, because those rules, for me, I don't know, they're a little difficult to remember. So what I'm going to do is show you my shortcut rule for this, and let's do this on our more examples. So let's start with number 4. We're going to graph this triangle, and then we are going to do our rotation. Okay, so number 4, clockwise rotation, but I want to start out by plotting my points. So let's plot these out. So P is at -1, 5. Okay, there's my P point. Q is at -5, 8. So -5 up to 8. There's our Q. And R is at -7, -2. So this one's a little trickier because it is kind of straddling the quadrants. But you will definitely see figures that do that. We need to know how to approach them. Okay, so this one is asking us for 90 degrees counterclockwise. So that means instead of going around to the right, we're going around to the left. So every point that's in the second quadrant goes into the third quadrant. That R point that's already in the third quadrant is going to have to go around to the fourth quadrant. So my trick is, however many 90-degree turns I have to run, that's how many times I have to flip my coordinates around. I'm doing one 90-degree turn. So first I'm going to flip my coordinates and then see where we're at. And so what I like to do for this is just write the numbers first, and then we decide what our signs are. So if I flip-flop my P coordinates, that means the 5 comes first and the 1 comes second. But it's going to end up in which quadrant? Yeah, that bottom left quadrant. So that means if I'm going to the left and down, both of my coordinates have to be negative. Will that happen with the Q as well? Well, yeah, he'll end up in that next quadrant down. So 1 turn, 1 flip, so 8 and 5. But because he's in the bottom left quadrant, both of those are negative. R, again, 1 90-degree turn, so 1 flip, 2 and 7. But R is a little different. He started out in that third quadrant, so he's going to end up in that fourth quadrant, bottom right, which means positive X, negative Y. So all I have to do is make sure I have a -7. Let's see if that works. Okay, so let's plot these out. And again, let's call this the pre-image. so we don't get confused as to which one's the new one. So new point, -5, -1. Okay. So that's the new P, so P prime. New Q is at -8, -5. So -8, -5, there's our new Q. Our new R is at 2, -7. So 2, -7. There's our new R point. So let's connect all the new points. There we go. So there's our new image. And it looks like we took the whole thing and just rotated it around. Awesome. Let's try another one. Okay, number 5, we have triangle RST. We're given those points, so same thing. Let's start out by plotting this. So actually, I'm going to change colors on this one because having the both red might have been a little hard to see. Let's do our new one in purple, or original one in purple. So R is at 2, 5. Okay, there's our R point. S is at 4, 7. There's S. And T is at 6, 1. So this one's not quite as tricky. So everything is in one quadrant, so it's going to be a little easier to keep track of where things are going on this one. Okay. What kind of rotation are we doing? We are doing 270 degrees clockwise. So how many 90-degree turns is 270? Right, that's 3 90-degree turns. So that means I'm going 1 90-degree turn, 2 90-degree turns, 3 90-degree turns. Everything we have is going to end up in that second quadrant. So that means when we are done, all of our signs will have to have a -x and a +y. We did 3 turns, so that means 3 flips. So we take our x and our y, we flip them once, we flip them back, we flip them a third time. So our x's and y's do look like they're flipped. We've got an odd number of flips in there. So that means our new R ends up as 5 and 2. But because we're in that top left quadrant, that means a -x, +y. Okay, S. Flip your x's and y's. Again, -x, +y. Same thing with your t's, flip them around. -x, +y. Again, let's make sure it works. So R is at -5, 2. There's our new R, R prime. S is at -7, 4, new S. And then T is at -1, 6, new T. Connect them up. And there is our rotated triangle. As always, let us know if you have any questions about what you saw. You can rewatch your video, but make sure you've written these problems down. Check the completed organizer if you need to. See you next time.